All sinusoidal functions are based on the sine and cosine curves. So that means sine x and cosine x are the parent functions of all sinusoidal functions. So there are some things you have to remember about sine x and cosine x parent functions. Both of them have a central axis at y equals 0. They both have a maximum value of 1. And they both have a minimum value of -1. Both start at 0 on the x-axis, and one complete cycle has a period of 360 degrees. The sine curve starts on the central axis and ends on the central axis, and halfway through it's also on the central axis. It goes up, reaches its maximum, then goes down, reaches its minimum, and goes back up again. And that's one complete cycle. For the cosine function, it starts at its maximum point and ends at its maximum point. Halfway in between, it's down at its minimum point. And it goes down, and then it goes back up. And that's what one complete cycle of a cosine function looks like. So if you memorize these boxes that I've just drawn for the sine and cosine curves, that'll help you as we go forward. Since sine and cosine functions are the parent function of all sinusoidal functions, you get the other functions by doing reflections, stretches or compressions, or shifts of the parent function. So if the parent function is y equals sine of x, you can apply 4 different transformations to that function, which I've labeled as A, K, D, and C. The lead coefficient, called A, tells you the vertical stretch or compression, or if the function is reflected. K tells you the horizontal stretch or compression or reflection. The value of D tells you the horizontal shift, so whether or not it's being moved left or right. This is also called a phase shift. And C tells you the vertical shift, whether or not it's going up or down. So for any sinusoidal function, you can start with your parent function and just apply these different transformations to it. So here is a function that I want to graph. Y equals 2 sine x plus 3. And I want to graph this over 2 cycles. So the first thing I need to notice in this function is that it's based on sine of x. So sine x is the parent function. And if you'll recall, this was my drawing of one cycle of the sine curve. So all the transformations are going to be applied to this sine curve. I'm going to draw a new box for my transformed function. So I'm going to draw a box with a maximum, a minimum, and a central axis. When I look at this equation, I notice there is a value of D. We're going plus 3. So remember, that's a vertical shift, and in this case, it's up 3. So that vertical shift is being applied to the central axis. So instead of starting at 0, it's going to start at 3. The next thing I want to notice is there's a transformation over here. That's an A value of 2. It's positive, So that means my curve is going to open in the same direction. So it's going to start and end in the same spot. In the middle, I'm going to be halfway in between. I'm going to go up to my maximum, down to my minimum, and back up. So I still have the same shape. But this 2 refers to a stretch. So it applies to my minimum and my maximum values. So instead of my maximum being 1, I'm going to multiply it by 2. So 1 times 2 is 2. So instead of my amplitude being 1, my amplitude is now 2. So I have to add 2 to my central axis. So that means my maximum value is 5. The minimum value on my parent function was -1. My amplitude was 1. But remember, I'm multiplying it by 2. So now instead of going down 1 from my central axis, I'm going down 2. So my minimum value is 1. So those are the only transformations being applied to the sine curve. I don't have anything that would affect my horizontal starting point or end point. So I'm just going to leave those the same. Halfway between 0 and 360 is 180 degrees. So now I can graph this. I'll start by making an appropriate scale on my x and y axis. So this box that I drew over here, it's going to help me when I'm graphing. I know my maximum value is 5 and my minimum value is 1. I know that my starting point on the x-axis is 0 and 1 cycle goes till 360 degrees. So I'm just going to draw this box on my actual grid over here. So there's the box, maximum of 5, minimum of 1, starts at 0, ends at 360. And the central axis is at 3. It's a sine curve, so I know it's going to start on my central axis and it's going to end at the same point for a complete cycle. Halfway in between those 2 points, I'm going to be on the central axis. Between the first and second points, halfway between those, I'm at the maximum. Halfway between my second or my middle and last point, I'm down at the minimum. So you just keep dividing by half and by half again. Now I just draw a smooth curve through my points. And there's one complete cycle of my function. But the question's asking to graph over 2 cycles. So what I'm going to do is I'm just going to repeat my pattern. So I'm just going to draw in another box for another cycle. I start on the central axis, I end at the central axis, halfway in between, I'm in the middle, halfway between those points, I'm up here, halfway between the last points, I'm down here, and I just repeat. And I could repeat this for any number of cycles just by copying and pasting that box that I have in yellow. And you can even take this function and go backwards into the negative x values. Here's another function that I want to graph. First thing I need to look for is whether it's sine or cosine. This one's cosine. So I know that my parent function is cosine, which roughly looks like that. So I'm going to set up my box just like I did the last time. When I look at the function, there's no c value at the end, so I'm not moving my central axis. So it's going to stay 0. My lead coefficient is -1. Since it's negative, my function isn't going to go this way, it's going to be a reflection. So it's going to open that way. The next thing I notice is that I have a d value.
Plus 45
in the brackets here. So instead of starting at 0 like my parent function, I'm going left 45 degrees. So that means I'm starting at minus 45 degrees. Just remember the sign is opposite whatever you have in the brackets in the equation. And the parent function ended at 360, but remember I'm going left 45. So that means instead I'm going to go to 315 degrees. There's nothing in the equation over here that would stretch or compress my graph, so my amplitude remains unchanged. That means I'll go up 1 from my central axis and down 1 from my central axis. So to graph this, I need to start by making an appropriate scale. So on the x-axis, I'm making every square is 45 degrees. I did that because I know I'm going to shift by 45 degrees to the left, so it just makes it easier. When I draw my box, I've got the maximum is 1, the minimum is -1. I'm starting at -45 on the left and ending at 315 on the right. So there's my box for one cycle. I know I'm going to start in the bottom left-hand corner, and I'm going to end in the bottom right-hand corner. Halfway between those 2 points, I'm going to be at the maximum value. Halfway between those first 2 points, I'm going to be on the central axis, and then the same on the other side. Draw a nice smooth curve. And that's one complete cycle. To draw 2 complete cycles, I'm just going to repeat the same pattern. So there you go. I just keep repeating the pattern as many times as necessary. For this function, you can see there are a lot of transformations being applied. I start by drawing my box, and I take note of the last number in the equation, my c value. It's -0.5. So that means I'm shifting my whole function down by 0.5. That means my central axis is at -0.5. My amplitude is 2, so that means my maximum and my minimum are up 2 and down 2 from my central axis. So if I go up 2, that brings my maximum to 1.5. And if I go down 2 from my central axis, my minimum value is -2.5. In the equation, I have this right here, x minus 180. This 180 refers to my horizontal shift, or my phase shift. That means instead of starting at 0, I'm going to be shifting to the right 180 degrees. That means my horizontal starting position is 180 degrees. The trickiest part is when you have a k value. So in this case, k equals 3. This refers to a horizontal stretch or compression, and it's kind of the opposite of what you would expect. So we're not multiplying by 3, we're actually going to be dividing by 3. And I'm talking about the period. The period is always equal to 360 divided by k. So in this specific instance, k is 3, so our period is going to be 360 divided by 3, which is 120. So that means from our starting point to the end point, that's a span of 120 degrees. That means I'm ending at 300 degrees for this transformed function. And now for the shape of this curve, it's a sine curve, and it's negative, so it's going to be vertically reflected. So it'll have that type of a shape. To make my graph, I'm going to start with an appropriate scale. And once I have my scale, I can draw in my box. So on the left, I'm starting at 180 and ending at 300. My maximum is 1.5 and my minimum is negative 2.5. My central axis is at negative 0.5. I start on the central axis, I end at the central axis, halfway between, I'm on the central axis. I go down to my minimum, I go up to my maximum, and there is one cycle of my function. And the question asks for 2 cycles, so I just repeat my pattern. But really, I can repeat it any number of times that I want. The cycle just keeps going and going forever in either direction. So when I get to a function like this, there's one thing you need to notice. This is not written the way we like. You need to make sure that inside here it's the factored form. So what I mean is, you might get tricked and think that you're moving the function left 90 degrees, when in fact, you're actually moving it to the right 45 degrees. You gotta watch out for that. Other than that, this question is the same as the last one. I start by setting up my box, and I notice I'm going down 2, so my central axis is at -2. My amplitude is 4, so my maximum and my minimum are 4 on either side of the central axis. I'm shifting my whole function to the right 45 degrees, so that means my starting point horizontally is 45 degrees, and my k value is 2. Which means my period is equal to 360 divided by 2, which is 180 degrees. So starting at 45, I'm going up 180 degrees to get to my end value, which is 225 degrees. The last thing you have to consider is the fact that there's a negative sign here. That means I'm reflecting horizontally. My parent function, y equals cosine of x, looked like that. If I reflect that horizontally, it ends up looking the same, has the same shape and direction. So for this instance, my graph doesn't really get affected. It's still going to start in the top left, end in the top right, halfway between it'll be at its minimum value. Just a side note, for horizontal reflections, when you're dealing with sine curves, the parent function, y equals sine x, looked like that. If I do a horizontal reflection, this point is now here, and this point is now here. So it actually does look different for a sine curve when you have a horizontal reflection. So back to this problem, I still need to graph my function. So I'm going to start by making an appropriate scale on my axes, and then I'll proceed to draw in the box to help me graph. So there's the box. My function starts in the top left, ends in the top right, halfway between I'm at my minimum, and then symmetrically on either side of that, it's at the central axis. Draw a smooth curve. So there's one cycle of my function. The question's asking me to draw this function between negative 360 degrees and positive 360 degrees. So I'm just going to draw as many of these cycles as I need. And there you have it. So to summarize, you can draw a box, figure out your central axis by looking at your C value, Then figure out your maximum and minimum by applying the amplitude. Use your horizontal shift to figure out your starting point. And then you figure out the period to determine your end point. Apply any reflections to see what shape your graph follows. And you just compare your shape with your parent function. Once you've done that, just draw your box on the grid and away you go.